All right, ladies and gentlemen, we're going to start our new unit today on quadratic equations. We're going to begin with a little bit of background information, some things that you know, and we're going to talk about how that's going to apply to our first task, which will be to find the roots of a quadratic equation. What does it mean to find the roots of a quadratic equation? First, let's look at a linear equation and a quadratic equation. Um, on the right, you see that the red line crosses the x-axis at a certain point, and you see that the quadratic equation, ax squared plus bx plus c equals 0, it crosses the x-axis in 2 points. So the root of the function, the definition for the root of a function, is that it's the x-intercept. So we have 2 x-intercepts on this function. So if we look back at the linear function, there's one x-intercept at the point 2, 0, but there are 2 for our quadratic function. And let's look at how to mathematically get to these. We can see them on the graph this way, but let's look at how we would get to them mathematically. For a linear equation, you've done this before. It's been a while perhaps, but to determine where the line crosses the x-axis, then you set y equal to 0, because as you see here, y is 0. And we take this formula and we drop 0 in for the y term and then solve for x, and we determine that x is equal to 2. So that's how we get our x-intercept of 2, 0 for this linear function. We're going to do something similar for the quadratic function, but it's just a little bit more complicated equation. So this is the standard form of a quadratic equation where we have a times x squared plus b times x plus c. So first we're going to start by taking this function and setting it equal to 0. That's what we did before. On the last one we set y equal to 0. We could have called this f of x equal to 0 as well. So before we begin, though, we want to make sure that we have the equation in standard form, which means that we have the ax squared plus bx plus c form. And we do. So we drop 0 in for f of x, and when we do that, then we can factor the equation. We're going to come back to what happened between here and here. That's a lot of steps. But for now, just trust me that this equation that you see plotted in blue on the grid is factored into the equation, the two binomials, x minus 2 times x minus 4. So to find the roots from this, we need to set each of these equal to 0. And we'll talk a bit about why that's the case in a moment. But if we set x minus 2 equal to 0, or x minus 4 equal to 0, we solve both of those and we get x equals 2 or x equals 4. So we confirm mathematically that the roots of the function are 2 and 4, and the x-intercepts are 2, 0, and 4, 0. So those are the roots of the function y equals x squared minus 6x plus 8. Next, how many roots can there be for a quadratic function? In this case, our first case, the one we started with, there were 2 roots. Here's more examples where there are 2 roots. So we have our parabola that crosses the x-axis in all 3 of these cases, and it crosses the x-axis twice. So there are 2 roots for each of the examples you see on your screen. Some of the parabolas open up, some of them open down. This one is symmetrical across the y-axis. This one resides mostly on the negative side of the x-axis. That's fine. It doesn't matter exactly where the parabola falls. It simply has to cross the x-axis twice, and it has 2 roots. This one, the one we started with, had 2 roots. There were 2 solutions. We can also have 1 root. So, for example, on this one where this parabola is just sitting right on the x-axis at the point 0, 0, this would have 1 root. Here are more examples of quadratic equations that would have 1 root. It could be, as this one is, at the point -3, 0, or at this one shows a root of positive 2, 0, a 1 root. So we can have 2 roots, we can have 1 root, or we can have no roots. So if the quadratic equation happens to be above or below the x-axis and does not cross the x-axis, then we have 0 roots for that quadratic equation. So that's kind of an interesting new twist. So in this little video, you've learned what a root is and how to find it mathematically. And you've learned that there are 2 roots, 1 root, or 0 roots for quadratic equations, and you can visually spot those. So we're working toward this target about solving quadratic equations by factoring. So in the next video, we'll go through that, and you'll be able to use all the skills that we talked about in this video to help you do that.